Now, in this video, we will going to take up one more problem on projections of lines and how to analyze this problem and solve this by using the sketchbook. Draw the projections of a line capital AB 100 mm long, inclined at 45 degrees to VP and 30 degrees to HP. One end of the line is 20 mm above HP and in VP. Determine the apparent length and inclination. Now to do that, now first we will going to consider the three-dimensional analysis, how to do that. Now if you consider this, now when you look from here, they draw the projections of a line AB 100 mm long, which is inclined at 45 degrees to VP and 30 degrees to HP. One end of the line is 20 mm above HP and in VP. You can see when you look from the front view, you can see that one end of the line is above HP now. It is 20 mm, he says. And also when you look from the top view, it is on VP. So that is the reason why the top view point A is on the XY line. So that you can see here, top view point of the line is on XY line. And when you look from the front view, you can see the distance above HP, which is 20 mm, and you mark that point as A dash. So you can see that you can mark that point as A dash. Then he says a line capital AB of 100 mm long. So since it is 100 and capital AB 100 mm long, so that means it is the true length, and which is inclined at 45 degrees to VP and 30 degrees to HP. So since it is 30 degrees to HP, the inclination of this 30 degrees to HP can be seen in VP. As one end of the point is in VP, obviously the other point should also be on VP, then only the line will be parallel. Therefore, you can see that on VP he has taken a 30 degree line which is inclined at 30 degrees and having 100 mm long. So then what happens when you look from the top view, the point of that will going to be lie on the XY line, which is the B1 here. That is AB1 is the line which is parallel to XY. You can see the same thing here with A dash center. So now he has drawn a line of 30 degrees at a distance of 100 mm, and when he has projected that, it is going to come on the XY line. You know this is the true length in the front view, so that means you have capital A and capital B. Since it is the true length in the front view, obviously that corresponding top view should be on XY line. So A is on XY line and B1 should also be on XY line. Therefore, you can see that AB1 is on XY line. Now that is what we have seen here. So now, and he says the same true length line is inclined to VP at 45 degrees. You can see that the same line, which is A, which is 20 mm above HP, and the B1 is also above HP by B2 is also above HP by 20 mm. Now the line is parallel to HP. Since the line is parallel to HP, so you can see the true length in HP. So obviously that line you can see, which is 100 mm long, which is inclined at 45 degrees, has got the true length because the line is parallel to HP. That means A dash B2 dash is the line which is parallel to XY line in the front view. So obviously that line in the top view will going to become the true length. Capital AB2 is the line which is in space where A is above HP by 20 mm and B2 should also be above HP by 20 mm. Therefore, when you look from the front view, you will going to get that as A dash B2 dash. That is what we have seen here with A as center, drawing a line at an angle of 45 degrees to a length of 100 mm. There you are going to get the locus of B in the top view. And since it is the true length of the line, so we have marked this as capital A and capital B. As we know, this is the true length of the line in the top view. Obviously, in the front view, you should get a parallel to XY line. So you can see that you have projected that point directly onto A dash line because A dash B2 dash is the front view line of the corresponding top view, which is AB2, which is the true length. So the front view line is parallel. So therefore, in the corresponding top view, you are going to get the true length. So it's the other way around because he has given AB2 is the line which has been given in the drawing, in the problem. So since it is the true length line, obviously that line has to be parallel to xy in the front view. So A dash is above HP by 20 mm. Therefore, B2 dash should also be above HP by 20 mm only. Then only the line is parallel to xy. So we are projecting this directly onto that line, so that A dash B2 dash is a horizontal line, which is above HP by 20 mm. So now actually what happens in the front view, you can see that the locus of B in the front view is here. So that is what we have seen. The locus of B in the front view is here. So which is that is this point. Now what we need to do, we need to find out the front view now. How to do that? With A dash as center, with capital A and capital B2, with A as center, taking the radius of A capital AB2, you rotate such that the point B, that is B2, will going to take a path on the vertical plane by taking the radius R, such that B2 will going to touch the locus of B in the front view here. So therefore, the line will going to become in space. Then that will going to be the point where it will going to cut the locus of B. So that point will going to be B dash. Then you are projecting that directly onto the vertical plane when you are looking from the front view. So therefore, you will going to get it as A dash B dash, which is drawn in the dot line. So that is what we have shown here. As we rotate it in space from capital A with capital A as center, taking the radius of AB2, when you are rotating such that B2 will going to cut the locus of B in the front view. So till such height, it will going to be rotated. So you are going to get this line as capital EB. So that is what you are doing here with A dash as center, taking the radius of A dash B2 dash. It is rotated such that it will going to cut the locus of B in the front view. You mark that point as B dash and join A dash B dash with a dot line. So that will going to be the apparent inclination with respect to HP. Similarly, so what happens now? We want to find the top view now. So to find the top view, what you have to do? We have to take this line capital AB, and then when you rotate, because I need to find out the top view. Since I need to find out the top view, how to rotate that now? So rotate that as with you have capital A dash B1 dash, because AB1 is the line which is on the vertical plane, because capital A is on VP. Obviously the point B1 should also be on VP. But what happens that B that is the B1 is not on VP. Instead, that B1 is in front of VP. That is because this is the distance what we are talking about, which will going to be the locus of B in the top view. So with A dash as center, taking the radius of A dash B1 dash, or with capital A as center, taking the radius of capital EB1, you rotate such that B1 will going to cut the locus of B in the top view here. So that means B1 will going to come in front of VP such that it will going to touch the locus of B in the top view, which is at this point. You will going to get it as capital EB, which is in space. So as we rotate like this in the space, then what happens to the image? As we look from the top view, the image small AB1 with A as center, taking the radius of AB1 is being rotated such that it will going to cut the locus of B in the top view at this point, and we mark this point as B and join AB with a dot line. That is what we have shown here with A as center, taking the radius of AB1, you draw an arc such that it will going to cut the locus of B in the top view, and you are going to mark this point as small b, then join A and B with a dot line, and when you join B and B dash, both will going to lie on the same line. So this is how you will be able to analyze in 3D and as well as in 2D by using the orthographic view. Now we will try to analyze by the stepwise. See, the same thing what we have done, we are considered with individually. So initially what we do, with A is above HP by 20 mm and it is on VP. Then we know the true length of the line, which is 100 mm, which is inclined at 30 degrees to HP. And we know the true length of the line in the top view, which is at 45 degrees, also inclined, also having a length of 100 mm. So therefore, you are going to have capital A and capital B in the front view and capital A and capital B in the top view. So that is what we have shown here in the 3D space also. Now what we want to do is, I need to find out the top view. To find out the top view, we have to take the front view line. You know that the front view is in true length, so obviously its corresponding top view should be in parallel to xy. We know that A is in VP, so B1 should also be on VP. Then only the line will be parallel to xy in the top view. So you will project this B1 dash directly onto the xy line because A is on VP. So B1 should also be on VP. So that is what we have shown here. So, but due to the presence of this line, which is capital AB, AB2, which is here, so I am rotating that capital B1, which is in front of VP, such that it will going to come and touches the locus of B in the top view, which is in space now. When it is projected, it will be at this point, join capital A and B, which will going to be the line which is in space. Now, but what happens to the image? Image is also being get rotated. Therefore, with A center, taking the radius of AB1, you are rotating such that the locus of B will, such that the B1 will going to touches the locus of B here, and we mark this point as small b, then join A to B with a dot line. So we have the beta inclination now. Similarly, what we can do is from the front view, the other way around. So here we have the top view line, top view true length, and then we have to this I need you have the front view true length also. We have the locus of B in the front view and as well as the locus of B in the top view. Now we know that pretty well this is the true length in the horizontal plane. Obviously that is true length in the top view. Obviously it should be parallel to xy in the front view. A dash is above HP by 20 mm. So B2 dash should also be above HP by 20 mm. Then only the line is parallel to xy in the front view. So you have A which is already fixed. So I am projecting B2 directly onto the locus of A in the front view. So you are going to get this point as B2 dash. Then A dash B2 dash is the line which is parallel to xy. That is what we have shown here. A dash B2 dash is the parallel to xy. Then with A center taking the radius of AB2, you are rotating in space such that it will going to touch the locus of B in the front view, which is at this particular height, which is above HP. So that means I am rotating that B2 in AB2 so that the B will going to be in front of above HP by this distance. So now that means as we rotate it in space, what happens to the image? Image is also being get rotated such that with A dash center taking the radius of A dash B2 dash, you are rotating such that it will going to touches the locus of B in the front view, and you mark this point as B dash, then join A dash B dash with a dot line. That is what we have shown here. With B2, from B2 you draw a vertical projector such that both A dash B2 dash will be above xy line with 20 mm. With A dash center taking the radius of A dash B2 dash, you rotate it such that it will go to touches the locus of B in the front view, and you mark this point as B dash, then join A dash B dash with a dot line. Then you measure the angle alpha and also the length A dash B dash. So that is what you have got the solution. Now if you want to draw by using the sketchbook, so how to start with the drawing? First we are going to draw the xy line, and you mark VP and HP. Then you take any point on the xy line because A is on point A is on VP and 20 mm above HP, and you mark this point as small a. Then draw a vertical projector to the front view, and you measure a distance of 20 mm and you mark this point. You mark this point as A dash. Then what you need to do, through A dash you draw a horizontal projector parallel to xy line, and then by using the protractor with A dash as center, taking the angle as 30 degrees with respect to this horizontal line, you measure an angle of 30 degrees and draw an inclined line. Similarly, with A center with respect to the xy line, you measure 45 degree below xy line by using the protractor and then draw an inclined line. Then by using the compass with A dash as center, taking the radius of 100, cut an arc on this 30 degree line. Similarly with A center, taking the radius of 100, cut an arc on this 45 degree line. Then you join A dash and B1 dash with a little bit thicker than the xy line. So you will going to mark this point as capital A and capital B, and you mark this point as B1 dash. As we got the B1 dash, then draw a locus of B in dash dot line and write it as locus of B in the front view. Similarly, by using the compass, take the radius of 100, cut an arc on this, you will going to get this point B2, and you mark this point as B2 and write this as capital A and capital B. then join AB2 with little bit thicker than the XY line. Then draw a dashed outline through B2, draw a dashed outline which is going to be the locus of B in the top view. Then as we know that this is the true length in the right capital A and capital B in the top view also. As we know that it is the capital A and capital B in the front view, that means it is the true length line in the front view. Its corresponding top view should be parallel to XY. So that means A is on VP, so B1 should also be on VP, that is on XY line. So draw a vertical thin projector line from B1 dash to the XY line and you mark this point as small B1. Then by using the compass with A as center, taking the radius of AB1, draw an arc such that it will go to cut the locus of B in the top view here and you mark this point as small b. Then join A to B with a dark line. So here you show the angle as beta and you show this angle as 45 degrees. Then what we need to do now, we have drawn a horizontal line through A dash. Then from B2 you draw a vertical projector such that it will go to touches the A dash line here and you mark this point as B2 dash. So that means A dash B2 dash is the parallel to XY line in the front view because the true length in the top view is AB2. So which is capital A and capital B. Then with A dash as center, taking the radius of A dash B2 dash, you draw an arc such that it will going to cut the locus of B in the front view here and you mark this point as B dash and join A dash B dash with a dark line. In the end what we need to do is, whether your drawing is right or wrong, then you may draw a line from B and B dash, both will going to lie on the same line, so that means your drawing is right. Then you show the dimension of 100, you show 20 mm here and then angle 30 degrees, angle 45 degree and then angle alpha. Then how to write the answer? Determine the apparent length and apparent inclination, means it is what we are talking about is the front view and its inclination and the top view and its inclination. So by using the scale you measure the distance from A dash B dash, which will going to be 70.71 when you do it in computer. When you are doing it in manual it will be 71, and then by using the scale you measure the length of AB, which will be 86.6 when you are doing it in computer. When you are doing it in manual it will be 87 mm. Then by using the protractor with A dash as center with respect to A dash B2 dash line, you measure the angle alpha, which will be equal to 45 degrees exact, and by using the protractor with respect to the XY line you measure the angle beta below the XY line, which will going to be 54.74 degree when you are doing it in computer, but when you are doing it in manual it will be 55 degrees. So this is how you will be able to analyze the problem in 3D and show how this will going to work in the orthographic view, and also how to solve by using the sketchbook. So this is how you will be able to find the solution. Thank you.